The story we've been told about human civilization is simple. Primitive hunter-gatherers gradually developed agriculture around 10,000 years ago, built the first cities, invented writing, and slowly progressed to our modern technological society. But what if this narrative is fundamentally wrong? What if advanced civilizations existed thousands of years before we thought possible, possessing knowledge and capabilities that rival or exceed our own? Today we'll explore the evidence that challenges everything we think we know about our past, examining ancient peoples whose achievements suggest a far more complex and mysterious human history than mainstream archaeology admits. Traditional archaeology places the first complex civilizations around 3500 BCE, with the rise of Mesopotamia and Egypt. Before that, we're told, humans were simple farmers and nomads with basic tools and no written language. This timeline has one fundamental problem. It doesn't explain the sudden, explosive emergence of sophisticated civilizations that appeared seemingly overnight, with advanced mathematics, astronomy, engineering, and social organization. How did humans go from living in mud huts to building massive pyramids and creating complex legal systems in just a few centuries? The conventional explanation of gradual development falls apart when we examine the actual evidence left by these ancient peoples. The evidence suggests that human civilization is far older and more complex than mainstream archaeology admits. From the sophisticated astronomy of the Maya to the engineering marvels of the megalith builders, from the sudden appearance of the Sumerians to the mysterious knowledge of the Dogon, patterns emerge that challenge our understanding of human development. These ancient peoples possessed knowledge and capabilities that rival or exceed our own in many areas. Their monuments continue to baffle modern engineers. Their astronomical calculations surpass our accuracy, and their cultural achievements suggest levels of organization and planning that we struggle to match. Perhaps most importantly, their traditions consistently warn us that civilizations rise and fall in cycles, that knowledge can be lost as well as gained, and that our current technological society may be neither the first nor the last to emerge on this planet. The question isn't whether we are the first advanced civilization on Earth. The evidence strongly suggests we are not. The question is whether we will learn from the patterns of the past and break the cycle of rise and fall, or whether future archaeologists will puzzle over our ruins as we now puzzle over theirs. The ancient peoples left us messages encoded in stone and preserved in tradition. They tell us that knowledge without wisdom leads to destruction, that technological power without spiritual development ends in catastrophe, and that true civilization requires balance between material advancement and understanding of our place in larger cosmic cycles. As we stand at the threshold of potentially transformative technologies, artificial intelligence, genetic engineering, space exploration, we would do well to remember the lessons of our predecessors. They achieved remarkable things, but they also failed. Their success and failure both offer guidance for navigating the challenges ahead. We are not the first, but we may be the first to have access to the complete historical record of previous attempts at lasting civilization. This knowledge is perhaps the greatest gift our ancestors could leave us, if we have the wisdom to use it well. In the marshy plains of southern Mesopotamia, around 3500 BCE, something extraordinary happened that would forever change our understanding of human development. The Sumerians didn't gradually evolve from primitive tribes into a sophisticated civilization. They appeared fully formed, with advanced knowledge that seems to have materialized from nowhere. This sudden emergence presents one of archaeology's greatest mysteries and challenges everything we've been taught about the slow, steady progress of human civilization. Traditional archaeological theory suggests that complex societies develop gradually over thousands of years. Hunter-gatherers slowly learn agriculture. Small villages grow into towns. Towns become cities, and eventually sophisticated civilizations emerge. This process should take millennia of trial and error, gradual learning, and incremental improvement. Yet the Sumerians defied this entire model. Within a remarkably short period, they had developed writing, mathematics, astronomy, complex legal systems, urban planning, and engineering capabilities that wouldn't be matched for thousands of years. The city of Uruk, one of the world's first true cities, housed over 50,000 people by 2900 BCE. This wasn't a collection of mud huts clustered around a water source. It was a planned metropolis with sophisticated infrastructure. The city featured massive walls, complex irrigation systems, monumental architecture, and organized districts for different crafts and social classes. The level of organization required to support such a population density suggests administrative capabilities that rival modern city planning. Yet, according to conventional timelines, these people had only recently transitioned from nomadic lifestyles. The Sumerian writing system, cuneiform, represents another impossible leap. Writing is considered one of humanity's greatest intellectual achievements, requiring abstract thinking, symbolic representation, and systematic organization of knowledge. Most cultures took centuries to develop even basic writing systems, starting with simple pictographs and gradually evolving toward more complex symbolic representation. The Sumerians appeared with a fully developed writing system capable of recording complex legal documents, literary works, mathematical calculations, and administrative records. Their earliest tablets show the same sophistication as documents created centuries later, suggesting they had mastered writing before they began creating the archaeological record we can study. Their mathematical achievements border on the miraculous. The Sumerians developed a base 60 number system that we still use today for measuring time and angles. This mathematical framework requires understanding of abstract numerical concepts that shouldn't have been possible for people supposedly just emerging from prehistoric conditions. They calculated square roots, understood geometric principles, and created mathematical tables that demonstrate advanced computational abilities. Their astronomical observations were equally sophisticated, tracking planetary movements with precision that required generations of careful observation and mathematical analysis. The Sumerian legal system reveals another layer of impossible sophistication. The Code of Uranmu, dating to around 2100 BCE, contains complex legal principles, including proportional punishment, monetary compensation for crimes, and distinctions between different classes of society. This wasn't primitive tribal justice. It was a sophisticated legal framework that suggests centuries of legal evolution and philosophical development. Yet these same people supposedly had no previous experience with complex social organization. Perhaps most intriguingly, the Sumerians themselves claimed they didn't develop these capabilities independently. Their creation myths and historical records consistently state that their knowledge came from the Anunnaki, beings they described as those who came from heaven to earth. These weren't abstract gods dwelling in some spiritual realm. Sumerian texts describe them as physical beings who taught humans the arts of civilization. The Anunnaki supposedly taught agriculture, metallurgy, astronomy, mathematics, and social organization to primitive humans who had been living as nomadic hunters and gatherers. The Sumerian king list presents another puzzle that challenges conventional understanding of human development. This ancient document records rulers with impossibly long reigns, some lasting tens of thousands of years. After describing these antediluvian kings, the text states that a great flood swept over the earth, and afterward, kingship was lowered from heaven once again. This suggests either incredible longevity among early rulers or a completely different understanding of time and historical cycles. The document treats these enormous time spans as historical fact rather than mythology, recording them alongside more conventional rulers whose reigns can be verified through other sources. Archaeological evidence supports the Sumerian claims of receiving knowledge from external sources. Their metallurgy techniques show advanced understanding of alloy composition and sophisticated smelting methods that should have required centuries of experimentation to develop. They worked with bronze, silver, gold, and other metals using techniques that wouldn't be rediscovered in other parts of the world for thousands of years. Their jewelry and decorative objects display craftsmanship that rivals modern techniques, suggesting access to knowledge and tools that far exceeded what their supposed technological development should have allowed. The Sumerian irrigation systems represent another impossible achievement. These weren't simple canals dug to channel water. They were complex hydraulic networks that required advanced engineering knowledge. The systems included locks, regulators, and distribution networks that maintained precise water flow across thousands of square miles. Modern engineers studying these ancient systems have found design principles that weren't rediscovered until the industrial age. The precision and sophistication of these hydraulic works suggest that their creators possessed engineering knowledge equivalent to modern civil engineering degrees. Sumerian medicine presents yet another anomaly. Medical texts from ancient Sumer describe surgical procedures, pharmaceutical preparations, and diagnostic techniques that demonstrate advanced understanding of human anatomy and disease processes. They performed cataract surgery, set broken bones with sophisticated splinting techniques, and used a pharmacological arsenal that included hundreds of plant and mineral remedies. This medical knowledge couldn't have been developed without centuries of careful observation, experimentation, and accumulated learning. Yet it appears fully developed in the earliest medical texts we can find. The religious and philosophical sophistication of Sumerian culture also defies explanation. Their creation myths demonstrate complex understanding of cosmology, natural cycles, and human psychology. The Epic of Gilgamesh, one of humanity's earliest literary works, explores profound themes of mortality, friendship, the nature of civilization, and humanity's relationship with the divine. This level of philosophical sophistication suggests a culture with centuries of intellectual development, not a society that had recently emerged from prehistoric conditions. Perhaps most mysteriously, Sumerian astronomical knowledge demonstrates awareness of celestial phenomena that shouldn't have been observable without advanced instruments. They tracked the precession of the equinoxes, a 26,000-year cycle that requires extremely precise observation over many generations to detect. They knew about planets that aren't visible to the naked eye and understood orbital mechanics that wouldn't be rediscovered until the development of modern telescopes. Their star charts show knowledge of constellations and celestial movements that suggest access to observational tools and mathematical techniques far beyond what conventional archaeology attributes to their civilization. The sudden appearance of the Sumerians with fully developed civilization capabilities forces us to reconsider fundamental assumptions about human development. Either human beings are capable of much more rapid cultural and technological advancement than we previously believed, or the Sumerians had access to knowledge from sources we don't fully understand. Their own records consistently point to external sources of wisdom, describing teachers who came from elsewhere and provided the foundation for human civilization. The Sumerian legacy extended far beyond their own culture. Their innovations in writing, mathematics, law, engineering, and social organization became the foundation for all subsequent civilizations in the region. The Babylonians, Assyrians, and other Mesopotamian cultures built directly upon Sumerian achievements, but none of them matched the sudden, dramatic leap that characterized the original Sumerian emergence. This pattern suggests that the Sumerians represented a unique moment in human history when advanced knowledge was transmitted to developing human societies, creating a civilization that served as the template for all future cultural development in the ancient world. The mystery of the Sumerians remains unsolved, but their legacy continues to challenge our understanding of human capabilities and the development of civilization. They achieved in centuries what conventional theory suggests should have taken millennia, and they did so while claiming their knowledge came from external sources. Whether we accept their explanations or seek alternative theories, the Sumerians force us to acknowledge that the story of human civilization is far more complex and mysterious than we have been taught to believe. When Plato wrote about Atlantis in his dialogues Timaeus and Critias around 360 BCE, he wasn't crafting a philosophical allegory. He was recording what he claimed to be genuine history passed down through Egyptian priests who maintained records spanning thousands of years. According to these ancient sources, a powerful maritime civilization had dominated the Atlantic Ocean 9,000 years before Plato's time, placing its existence around 9,600 BCE. For centuries, scholars dismissed this account as pure fiction. But mounting archaeological evidence from beneath the world's oceans suggests that advanced civilizations did indeed exist during the period when Atlantis supposedly flourished. The timeline Plato provided places Atlantis at the end of the last ice age, a period of dramatic geological and climatic upheaval that fundamentally reshaped the Earth's surface. During the height of the last glacial maximum, around 20,000 years ago, sea levels were approximately 400 feet lower than today. Vast areas of what are now continental shelves were dry land, supporting ecosystems and potentially human settlements. As the ice sheets melted between 15,000 and 7,000 years ago, these coastal plains were gradually, or sometimes catastrophically, submerged, taking with them any evidence of the civilizations that might have thrived there. Recent underwater archaeological discoveries have revolutionized our understanding of this submerged world. Off the coast of India, in the Gulf of Kambat, sonar surveys have detected massive geometric structures buried beneath layers of marine sediment. Carbon dating of materials recovered from these sites indicates ages of 9,500 years or more, placing them squarely in the time frame when Atlantis supposedly existed. The structures show evidence of sophisticated urban planning, with what appear to be streets, buildings, and harbor facilities arranged in organized patterns that suggest advanced architectural knowledge. The Yonaguni Monument off the coast of Japan presents another compelling piece of underwater evidence. This massive stone structure, discovered in 1987, features precisely cut angles, flat surfaces, and geometric shapes that strongly suggest artificial construction. The monument includes what appear to be steps, platforms, and channels carved from solid bedrock. Geological analysis indicates that the area was above sea level until approximately 10,000 years ago, meaning any civilization that created these structures would have existed during the exact period when Plato claimed Atlantis flourished. Marine archaeologists working in the Mediterranean have uncovered additional evidence of sophisticated prehistoric civilizations. Off the coast of Malta, underwater surveys have revealed megalithic structures that appear to be extensions of the island's famous above-ground temples. These submerged ruins show the same construction techniques and architectural styles as the surface monuments, but their underwater location indicates they were built when sea levels were much lower. The implications are staggering. Malta's temple civilization was apparently much larger and more extensive than previously imagined, with major portions of their settlements now lying beneath dozens of feet of water. The Black Sea region provides perhaps the most dramatic evidence for rapid coastal inundation that could have destroyed advanced civilizations. Marine geologist Robert Ballard and others has confirmed that the Black Sea was once a much smaller freshwater lake, separated from the Mediterranean by a natural land bridge. Around 7,600 years ago, rising Mediterranean waters breached this barrier, causing a catastrophic flood that raised the Black Sea's level by hundreds of feet within a matter of months or years. This event, which some researchers believe inspired the global flood myths found in ancient cultures worldwide, would have instantly submerged thousands of square miles of populated coastland. Underwater exploration of the Black Sea has revealed remarkably preserved archaeological sites, including ancient shorelines, riverbeds, and what appear to be human settlements. The anoxic conditions in the deep Black Sea have preserved organic materials that would normally decay, providing an unprecedented window into prehistoric life. These discoveries suggest that the Black Sea flooding was indeed catastrophic for human populations living in the region, potentially destroying entire civilizations and forcing survivors to flee to higher ground, carrying with them memories of a great deluge that destroyed their homeland. The advanced capabilities that Plato attributed to Atlantis find parallels in archaeological evidence from around the world during the post-glacial period. He described Atlantean mastery of metallurgy, including work with a mysterious metal called orichalcum, which was said to be second only to gold in value. Recent analysis of ancient metal artifacts from various Mediterranean sites has revealed sophisticated alloy techniques that produced metals with properties superior to pure copper or bronze. Some of these alloys contain element combinations that wouldn't be rediscovered until modern times, suggesting that ancient metallurgists possessed knowledge that was subsequently lost. Plato's description of Atlantean architecture featuring concentric circular cities with elaborate harbor systems and canal networks seemed fantastical until similar designs were discovered at archaeological sites worldwide. The ancient city of Tartessos in Spain, which disappeared around 500 BCE, was described by classical authors as having a circular layout with concentric rings of canals. Archaeological surveys of the region have identified geological anomalies consistent with buried circular structures, though the site remains largely unexcavated. Similar circular city layouts have been identified in aerial surveys of ancient sites in Peru, Cambodia, and other locations, suggesting that this architectural approach was more widespread than previously believed. The maritime technology that Plato attributed to Atlantis also finds support in archaeological evidence. Ancient harbor installations discovered throughout the Mediterranean show engineering capabilities that rival modern port facilities. The harbor at Caesarea Maritima, built by Herod in the 1st century BCE, employed underwater concrete that has proven more durable than many modern formulations. Similar advanced harbor construction techniques have been identified at much older sites, suggesting that sophisticated maritime engineering knowledge existed long before classical times. Navigation capabilities described in ancient texts also suggest that prehistoric civilizations achieved remarkable maritime accomplishments. The Polynesian settlement of the Pacific Islands required navigation skills that enabled voyagers to traverse thousands of miles of open ocean using only star charts and natural indicators. Archaeological evidence shows that this process began much earlier than previously thought, with some Pacific islands showing human habitation dating back 40,000 years or more. If prehistoric peoples could successfully navigate the vast Pacific, they certainly possessed the technological capabilities necessary for the kind of oceanic empire that Plato described. Ancient maps present another intriguing piece of evidence for advanced prehistoric knowledge. The Piri Reis map of 1513, compiled from ancient sources, shows Antarctica's coastline with remarkable accuracy, despite being created centuries before the continent was officially discovered. The map appears to show Antarctica as it would have looked before being covered by ice, suggesting that its ancient sources had access to geographical knowledge from a time when the continent was ice-free. Similar anachronistic geographical knowledge appears in other ancient maps, including accurate depictions of islands and coastlines that weren't officially charted until modern times. The cultural impact of Atlantis-like civilizations can be traced through mythology and oral traditions worldwide. Flood myths exist in virtually every ancient culture, describing advanced civilizations destroyed by rising waters. These stories share remarkably consistent details, despite originating in cultures with no known contact with each other. The similarities suggest either common historical origins or shared memories of actual events that affected human populations globally. The Sumerian flood narrative describes Utnapishtim preserving civilization through a global deluge. Hindu traditions speak of periodic cycles of destruction and renewal, with advanced civilizations regularly being destroyed by floods and other catastrophes. Native American traditions describe previous worlds that were destroyed by rising waters, forcing survivors to seek refuge on high mountains. These consistent themes across diverse cultures suggest that memories of catastrophic flooding and lost civilizations are deeply embedded in human collective memory. Modern climate research has confirmed that the end of the last ice age was marked by several periods of rapid sea level rise that could have caused exactly the kind of catastrophic flooding described in ancient texts. The meltwater Pulse 1A event, around 14,600 years ago, caused global sea levels to rise by 45 to 65 feet within just a few centuries. Meltwater Pulse 1B, around 11,400 years ago, caused another rapid rise of 15 to 25 feet. These events would have been catastrophic for any coastal civilizations, instantly submerging vast areas of inhabited land and forcing mass migrations to higher elevations. The search for Atlantis has expanded beyond the Atlantic Ocean to include potential locations worldwide. Researchers have proposed sites in the Mediterranean, the North Sea, the Caribbean, and even Antarctica as possible locations for Plato's lost civilization. While no single site perfectly matches Plato's description, the global distribution of underwater archaeological sites suggests that multiple advanced civilizations may have existed during the post-glacial period, each contributing to the collective memory that eventually became the Atlantis legend. The reality of lost civilizations beneath the waves forces us to reconsider our understanding of prehistoric human capabilities and the continuity of cultural development. If advanced maritime civilizations existed 10,000 years ago and were destroyed by rising sea levels, then human technological and social development may have been much more advanced much earlier than conventional archaeology suggests. The survivors of these lost civilizations may have carried their knowledge to new locations, seeding the rapid development of complex societies that appeared seemingly from nowhere in the archaeological record. Deep in the jungles of Central America, the Maya constructed more than cities and pyramids. They built monuments to time itself. Their civilization represents one of history's most compelling examples of advanced ancient knowledge, demonstrating mathematical and astronomical capabilities that wouldn't be matched in Europe for over 1,000 years. Yet the Maya achieved these intellectual heights while supposedly lacking basic technologies like the wheel, metal tools, and beasts of burden. This contradiction between their primitive material culture and their sophisticated understanding of cosmic cycles suggests access to knowledge that conventional archaeology struggles to explain. The Maya mathematical system was revolutionary in ways that modern people struggle to appreciate. While European mathematicians were still wrestling with Roman numerals and had no concept of zero as a mathematical placeholder, Maya scholars had developed a vigesimal system based on the number 20 that included sophisticated understanding of zero, place notation, and complex calculations. Their mathematical inscriptions demonstrate ability to work with numbers in the millions and to perform calculations involving incredibly precise fractions. These weren't simple counting systems developed for basic trade. They were advanced mathematical frameworks capable of supporting complex astronomical calculations and long-term calendar keeping that spanned thousands of years. The Maya calendar system represents perhaps humanity's most sophisticated achievement in temporal measurement. They simultaneously maintained multiple interlocking calendars that tracked different cycles of time with remarkable precision. The solar calendar of 365.2420 days was more accurate than the Gregorian calendar we use today. Their lunar calendar tracked the moon's phases with precision that allowed them to predict eclipses centuries in advance. Most remarkably, their Venus calendar calculated the planet's synodic period at 584 days, which differs from the actual period of 583.92 days by only 0.08 days, an accuracy of 99.99%. This astronomical precision required not just mathematical sophistication, but observational capabilities that seem impossible given their supposed technological limitations. Venus observations are particularly challenging because the planet is only visible for brief periods at dawn and dusk, and tracking its complete cycle requires continuous observation over many years. The Maya somehow maintained these observations with such precision that their calculations surpass many modern ephemeris cables. They accomplished this without telescopes, mechanical clocks, or precision instruments, suggesting either observational techniques we don't understand or access to knowledge from more advanced sources. The long count calendar demonstrates Maya understanding of vast time cycles that dwarf normal human experience. This system tracked days from a mythical creation date corresponding to August 11, 3114 BCE in our calendar, and was designed to continue for over 5,000 years until its completion on December 21, 2012. The psychological and intellectual sophistication required to conceive and maintain such a long-term temporal framework suggests a civilization that thought in terms of cosmic rather than human timescales. They weren't just tracking agricultural seasons or royal reigns. They were monitoring the universe's fundamental rhythms across millennia. Even more mysteriously, the Maya demonstrated knowledge of astronomical phenomena that shouldn't have been visible from their geographical location. Their texts reference stars and constellations that can only be seen from much different latitudes, suggesting either extensive travel networks or access to observational data gathered from around the globe. They tracked the Pleiades constellation's movement through cycles lasting 26,000 years, showing awareness of precession, the slow wobble of Earth's axis that causes apparent stellar positions to shift over vast periods. This astronomical knowledge required either thousands of years of continuous observation or inheritance of data collected by much earlier civilizations. Maya architectural achievements demonstrate engineering capabilities that complement their mathematical and astronomical knowledge. The pyramid at Chichen Itza incorporates sophisticated acoustic properties that weren't discovered by modern researchers until the 1990s. When visitors clap their hands at the base of the pyramid, the structure returns an echo that precisely mimics the call of the Quetzal bird, considered sacred by the Maya. This acoustic engineering required advanced understanding of sound wave physics and architectural design principles that seem impossibly sophisticated for a civilization lacking metal tools and precision instruments. The observatory at Caracal demonstrates Maya ability to integrate astronomical knowledge with architectural design. The building's windows and passages are precisely aligned to frame important celestial events, including Venus's maximum elongations, lunar extremes, and the rising points of various star groups. The complexity of these alignments required not just astronomical knowledge, but sophisticated surveying techniques and construction capabilities that could maintain precision across large structures. Modern archaeoastroastronomers studying the building continue to discover new alignments and astronomical functions that demonstrate levels of planning and execution that rival modern observatories. Maya hydraulic engineering reveals another dimension of their advanced capabilities. Recent LiDAR surveys have revealed extensive networks of canals, reservoirs, and water management systems that supported populations far larger than previously imagined. The city of Tikal alone contained a water management system that could support over 100,000 people during the dry season through sophisticated collection, storage, and distribution of rainwater. These systems included pressurized pipes, filtration systems, and distribution networks that demonstrate understanding of hydraulic principles that wouldn't be rediscovered in Europe until the Renaissance. The Maya understanding of human anatomy and medicine also suggests access to advanced knowledge. Their medical texts describe surgical procedures, pharmaceutical preparations, and diagnostic techniques that demonstrate sophisticated understanding of human physiology. They performed successful skull surgery, using techniques that left clear evidence of patient survival and healing. Their pharmacological knowledge included hundreds of plant-based medicines, many of which have proven effective in modern medical testing. This medical sophistication couldn't have been developed without extensive experimentation and accumulated knowledge that seems inconsistent with their supposed isolation from other advanced civilizations. Maya artistic achievements demonstrate technical capabilities that challenge conventional understanding of their technological limitations. Their jade working involved carving one of the hardest natural materials using techniques that produced incredibly intricate and precise results. Modern attempts to replicate Maya jade carving using supposedly period-appropriate tools have largely failed to match the precision and sophistication of original Maya work. The technical requirements for this level of stone carving suggest access to tools and techniques that conventional archaeology doesn't attribute to their civilization. The Maya writing system represents another intellectual achievement that seems disproportionate to their supposed technological development. Maya hieroglyphic writing was a fully developed system capable of recording complex historical, astronomical, and literary texts with remarkable precision. The intellectual sophistication required to develop such a writing system typically requires centuries of gradual evolution from simpler symbolic systems. Yet Maya writing appears in the archaeological record already highly developed, suggesting either rapid development or inheritance from earlier traditions. The Maya mathematical inscriptions demonstrate familiarity with advanced concepts that weren't developed in European mathematics until much later periods. They understood the concept of infinity, worked with complex series calculations, and developed mathematical tables that demonstrate understanding of exponential functions and logarithmic relationships. Their astronomical calculations required solving complex mathematical problems involving multiple variables and long-term projections that would challenge modern mathematicians working without computers. The Maya prophecy tradition suggests they understood history as cyclical rather than linear, with recurring patterns of rise, decline, and renewal that affected entire civilizations. Their texts describe previous world ages that ended in catastrophic destruction, followed by the emergence of new civilizations with different characteristics and capabilities. This cyclical worldview wasn't unique to the Maya. Similar concepts appear in Hindu, Greek, and other ancient traditions, but the Maya developed it with mathematical precision that allowed them to calculate the timing of these vast historical cycles.
The collapse of classic Maya civilization around 900 CE presents another mystery that challenges conventional explanations. At the height of their intellectual and artistic achievements, Maya cities were suddenly abandoned, leaving behind monuments and inscriptions that suggest the population simply vanished. Conventional explanations involving warfare, environmental degradation, or social upheaval fail to account for the suddenness and completeness of the collapse. The Maya themselves may have predicted this collapse, as their latest inscriptions show awareness that they were approaching the end of a major time cycle.
The Maya legacy continued through subsequent civilizations in Mesoamerica, but none achieved the same level of mathematical and astronomical sophistication as the classic period Maya. The Aztecs inherited Maya calendar systems and astronomical knowledge, but simplified and reduced their complexity. This pattern of declining sophistication over time suggests that the Maya possessed knowledge that was gradually lost rather than gradually developed, implying that their achievements represented the culmination of much older traditions rather than the beginning of new ones. Modern Maya communities maintain oral traditions that describe their ancestors as inheriting knowledge from even earlier civilizations that possessed capabilities far exceeding anything achieved during the historical period. These traditions speak of previous civilizations that could manipulate time itself, travel between worlds, and communicate directly with cosmic forces. While these accounts are dismissed as mythology by conventional archaeology, they provide a cultural context for understanding how the Maya themselves viewed their remarkable achievements in mathematics and astronomy, not as original developments, but as preserved fragments of much greater knowledge that had been largely lost. Scattered across the globe, from the wind-swept plains of England to the remote islands of the Pacific, stand monuments that defy every conventional explanation for their existence. These massive stone structures, built with precision that challenges modern engineering capabilities, represent technologies and organizational systems that supposedly didn't exist when they were constructed. The megalithic builders worked with stones weighing hundreds of tons, transported them across impossible distances, and assembled them with mathematical precision that requires advanced understanding of geometry, astronomy, and physics. Yet, according to conventional archaeology, these monuments were created by primitive peoples using only rope, wooden rollers, and human labor. Göbekli Tepe, in southeastern Turkey, represents perhaps the most revolutionary discovery in modern archaeology, forcing a complete revision of our understanding of prehistoric human capabilities. Dating to approximately 9500 BCE, this massive temple complex predates Stonehenge by 6,000 years and the Egyptian pyramids by 7,000 years. The site consists of enormous T-shaped limestone pillars, some weighing up to 20 tons, arranged in circular enclosures and decorated with sophisticated carved reliefs depicting animals, abstract symbols, and human figures. The precision of the stone carving and the complexity of the site's organization suggest capabilities that shouldn't have existed during what we consider the Stone Age. The implications of Göbekli Tepe extend far beyond its impressive age. The site required coordinated effort from hundreds or possibly thousands of workers over extended periods.
The limestone pillars were quarried from bedrock using techniques that left no tool marks, suggesting cutting methods more advanced than simple stone tools. The carved reliefs demonstrate artistic sophistication and symbolic thinking that indicates complex cultural and religious systems. Most mysteriously, the entire complex was deliberately buried around 8000 BCE, covered with thousands of tons of soil in what appears to have been a massive, coordinated effort to hide the site from future discovery.
The builders of Göbekli Tepe possessed astronomical knowledge that enabled them to align their structures with celestial phenomena. The circular arrangements of pillars create sightlines that frame important stellar risings and settings, suggesting that the site functioned as both a religious center and an astronomical observatory. The sophistication of these alignments required not just observational astronomy, but mathematical calculations that could predict celestial movements across long periods. This level of astronomical knowledge contradicts everything we thought we knew about the intellectual capabilities of hunter-gatherer societies. Stonehenge in England presents similar challenges to conventional understanding, though it was built thousands of years after Göbekli Tepe. The monument's construction required transporting massive sarsen stones weighing up to 50 tons across distances of over 20 miles, while the smaller blue stones were somehow moved from Wales, over 150 miles away. The precision of the stone placement creates astronomical alignments that track the sun's movement throughout the year with remarkable accuracy. Recent discoveries have revealed that Stonehenge was part of a much larger sacred landscape that included dozens of other monuments and earthworks, suggesting a level of regional planning and coordination that rivals modern urban development projects. The engineering challenges involved in Stonehenge's construction continue to baffle researchers. The trilithons, consisting of two vertical stones topped by a horizontal lintel, required lifting techniques that could position multi-ton stones with millimeter precision. The horizontal lintels were secured using mortise and tenon joints carved directly into the stone, demonstrating woodworking techniques applied to massive stone construction. Modern attempts to replicate these construction methods using supposedly period-appropriate technology have largely failed to achieve the precision and scale of the original monument. Easter Island's moai statues present perhaps the most puzzling megalithic mystery. Nearly 1,000 of these massive stone figures, some weighing up to 80 tons, were carved from volcanic rock and distributed across this remote Pacific island. Recent archaeological work has revealed that the statues have bodies extending deep underground, stating they are much larger and possibly much older than previously believed. The island's isolation, 2,300 miles from the nearest populated land, raises profound questions about how such a sophisticated stone-carving civilization could have developed in such a remote location. The Rapa Nui people who created the moai possessed navigation capabilities that enabled them to traverse thousands of miles of open ocean to reach Easter Island in the first place. This maritime technology, combined with their stone-carving expertise, suggests a level of cultural sophistication that seems inconsistent with their supposed isolation. The moai themselves demonstrate advanced understanding of sculpture, engineering, and possibly astronomy, as many of the statues are aligned with celestial phenomena. The precision of the carving work,
accomplished using only stone tools, required techniques that modern stoneworkers struggle to replicate.
The Olmec colossal heads in Mesoamerica represent another megalithic mystery that challenges conventional explanations. 17 of these massive sculptures, some weighing up to 50 tons, were carved from basalt quarried 60 miles away from their final locations. The heads display remarkable artistic sophistication and anatomical accuracy, but their most puzzling feature is their distinctly African appearance. The facial features, including broad noses, full lips, and other characteristics, strongly suggest African heritage, yet they were created in the Americas, thousands of years before any known contact between Africa and the New World. The transportation methods required to move the Olmec heads remain unexplained. The terrain between the basalt quarries and the final monument locations includes rivers, swamps, and mountainous areas that would have presented enormous challenges for moving multi-ton sculptures. The precision required to transport such massive objects without damage suggests engineering capabilities and organizational systems that conventional archaeology doesn't attribute to Olmec civilization. Some of the heads show evidence of deliberate defacement or modification after their initial creation, suggesting complex cultural or political reasons for altering these monuments. Sacsayhuaman in Peru showcases stone-fitting techniques that modern masons consider impossible to replicate. The massive limestone blocks, some weighing over 200 tons, are fitted together with such precision that a knife blade cannot be inserted between them. The stones are cut in complex, irregular shapes that interlock perfectly, creating structures that have survived centuries of earthquakes in one of the world's most seismically active regions. The precision of the stone cutting and fitting required measuring and shaping techniques that seem to exceed anything achievable with bronze or stone tools. The transportation challenges at Sacsayhuaman are equally mysterious. The limestone blocks were quarried from sites several miles away and had to be moved across difficult terrain that includes steep valleys and mountainous areas. The largest blocks would have required coordinated effort from thousands of workers, yet the precision of their placement suggests control systems that could position massive stones with incredible accuracy. Spanish chroniclers who witnessed similar construction techniques being used by the Incas described methods involving plant extracts that could supposedly soften stone, though no such technology has been verified by modern research. Baalbek in Lebanon contains some of the largest worked stones ever discovered. The trilithon consists of 3 limestone blocks, each weighing approximately 800 tons, that were somehow lifted and positioned 20 feet above ground level. Even more mysteriously, the quarry site contains an unfinished block known as the Stone of the Pregnant Woman, weighing an estimated 1,000 tons. Modern crane technology would struggle to lift stones of this size, yet ancient builders somehow planned to incorporate them into their construction projects. The precision of stone cutting at Baalbek demonstrates techniques that seem to exceed ancient technological capabilities. The massive blocks are cut with perfectly flat surfaces and precise right angles that would require advanced measuring and cutting tools. The stones fit together with minimal gaps, creating structures that have remained stable for thousands of years despite earthquakes and other natural disasters. Roman historians attributed the site's foundation to a race of giants, suggesting that even ancient peoples recognized the superhuman scale of the construction. The global distribution of megalithic sites suggests either a worldwide civilization with shared technologies or multiple independent cultures that somehow developed identical construction techniques. Similar stone-fitting methods appear at sites separated by thousands of miles and thousands of years, yet the techniques remain consistent. The astronomical alignments found at megalithic sites worldwide also show remarkable similarities, suggesting shared knowledge of celestial mechanics and mathematical principles. Modern analysis of megalithic sites using ground-penetrating radar and other advanced techniques continues to reveal hidden complexities that weren't apparent from surface examination. Many sites show evidence of underground chambers, water systems, and structural elements that suggest functions beyond simple monument construction. Some megalithic sites demonstrate acoustic properties that were clearly intentional, creating sound effects that enhance religious or ceremonial activities. The megalithic builders left behind monuments that continue to challenge our understanding of ancient human capabilities, yet they left no written records explaining their construction methods or purposes. This absence of textual evidence forces us to rely on the monuments themselves to understand the civilizations that created them. The scale, precision, and sophistication of megalithic construction suggest that our ancestors possessed knowledge and capabilities that far exceeded what conventional history attributes to them. Throughout history, certain cultures have served as unlikely repositories of knowledge that seems to transcend their apparent technological limitations. From the astronomical insights of the Dogon people to the sophisticated mechanisms of ancient Greece, these examples suggest that advanced understanding was not lost with hypothetical ancient civilizations, but rather preserved in fragments across the globe. This video examines how mysterious knowledge survived through oral traditions, secret societies, and remarkable artifacts that continue to challenge our assumptions about the capabilities of our ancestors. In the remote villages of Mali, the Dogon people have maintained an oral tradition that includes detailed knowledge of astronomical phenomena invisible to the naked eye. Their cosmology centers around Sirius, which they call Potolo, but their understanding extends far beyond what should be possible without advanced instruments. The Dogon speak of Sirius B, a white dwarf companion star that orbits Sirius A every 50 years. This companion star was not confirmed by Western astronomy until 1970, yet the Dogon have possessed this knowledge for centuries, passing it down through their priests and storytellers. They describe its extreme density, calling it the smallest and heaviest star, and accurately portray its elliptical orbit around the brighter Sirius A. Even more intriguing, the Dogon tradition speaks of a third star in the system, Sirius C, which some astronomers now suspect may exist based on gravitational perturbations observed in the system. Their star maps, drawn in sand during ritual ceremonies, show a level of astronomical precision that would require telescopic observation and mathematical calculations far beyond what conventional archaeology attributes to sub-Saharan African cultures of previous centuries. French anthropologists Marcel Griol and Germaine Dieterlen, who spent decades studying Dogon culture, documented these traditions in the 1940s and 1950s, well before modern astronomy confirmed many of these details. The Dogon elders insisted this knowledge came from their ancestors, who received it from visitors from the Sirius system itself, beings they called the Namo, described as amphibious teachers who brought civilization to Earth. The Mediterranean has yielded artifacts that demonstrate sophisticated technological capabilities in the ancient world. The Antikythera mechanism,
discovered in a shipwreck off the Greek island of Antikythera in 1901, represents perhaps the most complex piece of ancient technology ever found. This bronze device, dating to approximately 100 BCE, functions as an analog computer capable of predicting the positions of the sun, moon, and planets with remarkable accuracy. X-ray tomography and modern analysis have revealed the mechanism's intricate system of at least 37 bronze gears, each precisely cut and calibrated. The device could predict eclipses, track the 4-year cycle of the Olympic Games, and follow the 19-year metonic cycle that governs lunar phases. Its sophistication rivals clockwork mechanisms that wouldn't appear in Europe again until the 14th century CE. The Dogon educational system, centered around the Awa society and other ritual organizations, maintains this astronomical knowledge through carefully structured initiation processes. Knowledge is revealed gradually over decades, with the most profound secrets reserved for the highest-ranking priests and elders. This system has preserved complex information for at least 700 years and possibly much longer. The Dogon describe their knowledge as inherited from the earliest times, when their ancestors received instruction from the Nomo. These teachers are depicted in Dogon art as fish-like beings who emerged from the sky in a spinning arc that landed with great noise and wind. The Nomo taught the Dogon about astronomy, agriculture, and social organization before returning to their home in the Sirius system. What makes this tradition particularly compelling is its internal consistency and technical accuracy. The Dogon describes Sirius B's orbital period as 50 years, remarkably close to the actual period of 49.9 years. They know that Sirius B is composed of matter heavier than iron, and they correctly describe its orbit as elliptical rather than circular. These details could not have been observed without powerful telescopes and spectroscopic analysis. The Dogon also speak of a third star in the system, which they call Ma, or Sirius C. While this star has not been definitively confirmed by modern astronomy, some researchers have detected gravitational perturbations in the Sirius system that suggest the presence of a third body, possibly a red dwarf star or large planet. The Dogon have encoded their astronomical knowledge not only in oral tradition, but also in the physical layout of their villages and sacred sites. The arrangement of buildings, shrines, and ceremonial spaces reflects their understanding of celestial mechanics. Village layouts mirror the structure of the Sirius system, with key buildings positioned to represent the orbital relationships between the stars. Their calendar system incorporates multiple celestial cycles, including the Sirius B orbital period, lunar months, and solar years. Ritual ceremonies are timed to coincide with specific astronomical events, demonstrating practical application of their theoretical knowledge. The Dogon track precession, the slow wobble of Earth's axis that causes the apparent position of stars to shift over thousands of years, and use this knowledge to maintain accurate long-term calendars. The Bandiagra cliffs themselves serve as a massive astronomical observatory. Specific rock formations, caves, and cliff faces are used to mark solstices, equinoxes, and the heliacal rising of important stars. The Dogon have identified and named numerous stars and constellations invisible to casual observation, many of which correspond precisely to modern astronomical catalogs.
The Dogon are not unique in preserving advanced astronomical knowledge through oral tradition. Similar examples exist among other indigenous cultures worldwide, suggesting a broader pattern of ancient knowledge preservation. The Australian Aboriginal peoples maintain songlines that encode sophisticated understanding of celestial mechanics and navigation. Their Dreamtime stories contain accurate descriptions of stellar evolution, including the life cycles of stars and the formation of neutron stars. Archaeological evidence suggests these traditions may be 65,000 years old, making them among the oldest continuous knowledge systems on Earth. Native American tribes possess detailed astronomical knowledge embedded in their ceremonial cycles and architectural traditions. The Lakota speak of the Wolf Trail, Milky Way, in terms that demonstrate understanding of galactic structure. Pueblo astronomy includes knowledge of planetary cycles and stellar positions that require generations of careful observation to accumulate. Ancient Hindu and Buddhist texts contain cosmological descriptions that align remarkably with modern astrophysics. The Puranas describe universe cycles spanning billions of years and cosmic structures of incredible scale and complexity. These traditions, like the Dogon system, suggest access to observational capabilities or theoretical frameworks far beyond what conventional history attributes to ancient peoples. The evidence suggests that advanced knowledge was preserved not by individual cultures in isolation, but through networks of communication and exchange that spanned continents and millennia. Trade routes, migration patterns, and cultural exchanges created opportunities for knowledge transfer between distant civilizations. The Dogon tradition may represent one node in this larger network of preservation. Their knowledge could have originated from contact with other advanced cultures, from inherited traditions dating to much earlier civilizations, or from ongoing contact with sources of knowledge that conventional archaeology has not recognized. Similar preservation networks can be identified in other regions. The mathematical and astronomical knowledge that spread from India to the Islamic world and eventually to medieval Europe followed established trade and cultural exchange routes. The megalithic building traditions that appeared across Europe, Africa, and the Americas may represent another example of widespread knowledge transmission. The Dogon case, along with similar examples worldwide, challenges fundamental assumptions about the development of human knowledge and the capabilities of ancient civilizations. If semi-nomadic peoples in medieval Mali possessed accurate knowledge of binary star systems and quantum mechanical principles, what does this suggest about the true history of human intellectual achievement? The preservation of such knowledge through oral tradition demonstrates the sophistication of non-literate educational systems and challenges Western biases about the superiority of written culture. The Dogon have maintained complex technical information for centuries without books, using instead elaborate ritual systems, symbolic art, and carefully structured initiation processes. This suggests that much of what we consider lost knowledge from ancient civilizations may not be lost at all, but rather preserved in forms that modern scholarship has not learned to recognize or decode. Indigenous traditions worldwide may contain scientific and technical knowledge that predates and, in some cases, exceeds the achievements of classical antiquity. This knowledge was not randomly distributed, but carefully preserved by specific groups who understood its value and the necessity of protecting it through turbulent historical periods.
The guardians of this forbidden knowledge, from Dogon priests to mystery school initiates, served as links in a chain of transmission that spans millennia. Their dedication to preserving these teachings through the rise and fall of empires has left us with tantalizing glimpses of capabilities that challenge our understanding of human development. The Dogon people, in their remote villages along the Bandiagara cliffs, represent one of the most compelling examples of this preservation tradition, keepers of stellar knowledge that should have been impossible to obtain, yet has proven accurate in every detail that modern science can verify. The Dogon people's impossible astronomical knowledge stands as perhaps the most enigmatic example of ancient wisdom preserved against all odds. Their tradition suggests that the story of human civilization may be far more complex and ancient than conventional archaeology admits, and that profound knowledge of the cosmos has been carefully guarded by indigenous peoples whose true achievements remain largely unrecognized by mainstream scholarship. In the quiet villages along the Bandiagara cliffs, under the same stars their ancestors observed for centuries, the Dogon elders continue to pass down their sacred knowledge. They speak of visitors from distant worlds, of cosmic cycles spanning eons, and of truths hidden from the uninitiated. As we stand at the threshold of our own space age, discovering exoplanets and mapping the cosmos with unprecedented precision, we must ask ourselves, what if the ancients knew far more than we ever imagined? What if the real question is not how they could have known such things, but rather, what else did they know that we have yet to rediscover?